Okay, so good morning, everyone. I am your host, Rob Grillo from Trust IT Services, and I'm the lead of the DestinE editorial board. And I'm pleased to welcome you all to this webinar. This is SenCore and EAGLE AI-powered services for Earth observation workflows and real-world applications. So SenCore and EAGLE are two DestinE Platform services operated by Neuralio AI, and we have several representatives from the company with us here today, as well as from the DestinE platform, specifically from Circo. So SenCore supports real-time sensor data integration, helping users ingest, use, standardize, and analyze data streams from IoT devices and ground stations, while EAGLE provides a geospatial AI environment for Earth observation data processing and analysis. And this enables users to work with EO datasets, pre-trained AI models, object detection workflows, data annotation, model training, and interference through a user-friendly no-code interface. You'll hear more about that later. And specifically, this webinar will introduce these two services, presenting their key capabilities, supported workflows, and potential applications within the DestinE platform ecosystem. We'll also include examples of how these two services can support users in discovering, accessing, analyzing, and extracting value from EO and climate-related data. Now, of course, it's very nice for us to know a little bit more about you. So please, I invite you to join us in this very quick survey just for our colleagues to be more familiar with you. First question is, how familiar are you with AI-based tools for EO or climate data analysis? The other question is, what best describes your profile? And this just kind of gives us a little idea about who you are. Now, while you're filling in that poll, I'll give a few housekeeping reminders. Please do keep your questions until the end, as we have a dedicated Q&A session after the presentation and the demos. And to test out the chat and make sure you can ask your questions, feel free to say hi in the chat, tell us where you're connecting from. It's always good to know. Also, do note that the recordings will be published several working days after today. So do come back to the event page and on the DestinE website or in the Learning Hub in the DestinE platform to access the recordings. We will inform you once they have been published, so don't worry, you won't miss that. Hi there, George from Vienna, thanks. Okay, so while we're going through this, let's see our participants, who they are and where they're coming from. So in terms of familiarity with AI-based tools for EO or climate data analysis, the majority are actually new to this topic, so 43%. A little bit behind, we have a few that are familiar with the concepts, so about 29%, although they have not used them. But maybe after today's demo, we'll get that a bit more higher. 16% have said they have used them occasionally, and 12% have said that they use them regularly. So we have quite a few people that are, let's say, more on the newer side or not so aware side. So just bear that in mind. In terms of profiles, 40% are coming from the researcher academia area. We have 20% coming from the public sector or policy users. We have 16% that are from industry and private sector, 19% on the data science or developer side, and other. Okay, so I see the chat works, so that certainly works for the Q&A. I see we have people coming from Greece, Germany, hi from Copenhagen, Italy. Okay, so very nice. I think with that, I suppose we can start. So I will pass the floor first to Charalampos Paraskevas, who is from Neuralio AI, the R&D director and scientific lead. So Charalampos, over to you. Oh, sorry, I think your audio is not working. Could you try again? We need to switch. Okay, so I will end the poll now. In the meantime, there will be a second one later.
Can you hear me now?
Now it works, yes.
Sorry for disturbance.
No worries.
Hello, everyone. My name is Carlos Paraskevas from Neuralio. Here with me today are Dimitris Kasabalis, our Business Development Manager, and Apostolos Avdafiotis, our Solution Architect. Dimitrios will be your main host for today's session. Before we dive in, I want to thank you all for taking the time to be here and giving us the opportunity to present our two destination art services, SenCore and EAGLE. As a special highlight today, we'll be showcasing the brand new second version of EAGLE, which will be officially available on next week. I don't want to waste your time. Dimitris, the floor is yours.
Thank you, everyone. Let me share my screen. Is it visible? Can you see it?
Yes.
Yes.
Okay, so good morning, everyone. And thank you for being here. I am Dimitris from Neuralio, and over the next hour, I want to walk you through the two services that we operate as part of the destination Earth ecosystem, SenCore and EAGLE. Earth observation and environmental sensing have an abundance problems, not a scarcity problem. Today we have more data than ever before from more sources and higher resolution than we had in the past. What we don't have now is, in most operational context, is a clear path from those observations to a decision someone can act on. That gap is what SenCore and EAGLE are built to close from opposite directions. SenCore comes at it from the ground. You can monitor sensor networks, real-time streams, and EAGLE comes at it from above, satellite imagery and geospatial AI. First of all, let's put in frame who we are, because it's at the rest of the deck. Neuralio AI builds what we call decision intelligence for complex real-world systems. And by complex real-world systems, we mean things like defense, energy infrastructure, cities, climate operations, strategic supply chains, etc. The common thread across those domains is that decisions have to be made under uncertainty with incomplete information, often in real time, and they have physical world consequences. Our work sits in the intersection of these six capabilities we see across the top. And the thing I wanted to take from this slide is that we don't sell any of these things in isolation. The value is in intersection. The satellite feed without a model that you can interpret is just pixels on an image. A model without a decision workflow on the other hand, is a research output. The integrated layer is the product that we offer here. So SenCore and EAGLE are how that philosophy lands inside the DestinE Platform, and they are the operational expression of this thinking. So this is the strategic frame slide here, and I want to spend some time here because it explains the design choices in later on. The central observation is that the critical systems today have more data than they ever had before, but they don't have we don't have better decisions. The decision quality has not kept pace with the data growth in many domains. And the gap is actually widening. The reason that the gap exists is structural and not technological in most of the cases, and that is the layer between observation and decision is fragmented across half a dozen of different vendors, formats, and teams. And here we set out to build that layer as a single thing. Three priorities that distinguish what we built is a full stack with data, model, simulation, and decision workflows in one integrated system, designed together rather than bolted together. Operational, built for environments where decisions matter and have consequences, not for dashboards or pilots that have never leave the lab. And cross-domain, the same underlying layer serves defense, energy, cities, climate and supply chains, because the decision-making patterns are more similar across domains than people assume. With that in frame, let's look what we actually built on the destination platform. Two services, both live on a DestinE today. SenCore, that handles real-time environmental monitoring, anything that streams from a sensor in the field, air quality stations, weather stations, water sensors, soil sensors, custom IoT deployments, and EAGLE, that handles Earth observation processing and geospatial AI, satellite imagery from different data providers. The user can upload its own data, and the model pipelines that turn that imagery into structured outputs. We have different inputs, different primary uses, but they share the same operational goal, that take raw observations and turn them into something you can act on end-to-end without leaving the platform. They are explicitly complementary, those two services. And when you look at the real operational problem, you say monitoring, say, for example, monitoring in industrial site, or tracking a wildfire, or managing a water sink, you often want both sensor data and satellite data, and you will want them in the same system. That's why we want to present these services together here. Another reason that we put these two together and not in a two separate webinars is that the problem in this space is not the data access, as we said. DestinE already gives world-class access to Earth observation data and sensor feeds. The problem is that the end-to-end workflow from observations to reusable, shareable operational output. So that workflow has the same shape regardless of where the data comes from. So you ingest the data, you pre-process them, you reason, and you produce an output that someone else can use. Sensor solves this for ground-based sensors, and EAGLE solves it for satellite Earth observation data. Together, they cover the two main observation modalities of the platform, and they cover them in the same architectural style. So once you have learned one, the second one feels a bit more familiar. One mental model to carry through the rest of the session is that every real-world decision pipeline, regardless of the domain, has 4 stages: observe, process, reason, and act. Observe is where the data comes in. Process is where you clean it, transform it, unlike it. And the reason is where you apply rules, models, or analytics to extract meaning. Act is where the output reaches a human or another system that does something with it. SenCore and EAGLE can take you through the full arc for their domain. When we get to the demos, we will see these 4 stages for each of these services, and you will see this pattern come over and over again. So let's start with SenCore. SenCore is our real-time environmental monitoring service that from distributed sensor networks to wearable alert-ready environmental intelligence. In order to deform this sentence, when we mean from distributed sensors, means that you probably got equipment in a lot of different physical locations, maybe from different vendors, maybe acquired over the years. Queryable means that you can ask spatial and temporal questions about the data and they get an answer in seconds. And alert ready means that the system actively watches your streams of data and tells you when something needs your attention. For example, air quality networks, weather stations, hydrology monitoring, soil and agriculture, smart cities sensing, industrial monitoring. Those are the use cases that we see most often that use this kind of service. So on the next slides, we will go through the capability stack of this service, and you will get an idea how, what SenCore has to offer to you. You start with the inbox. You get the data into the platform, how to get the data from different sensors in the platform. For example, field equipment in environmental monitoring can speak many different protocols. HTTP for the modern equipment, MQTT for almost anything IoT, FTP for older industrial equipment that still drops CSV files on a schedule, and a long tail of vendor proprietary protocols on top. SenCore accepts the protocols your devices already can stream and distribute. You don't have to retrofit firmware. You don't have to stand up a translation bridge. You don't have to build a custom adapter for every vendor. So this may sounds like a small thing, but operationally this is huge because most environmental networks aren't greenfield deployments. You are inheriting hardware that has been bought 5 or 10 years ago and that you can't replace. So SenCore is built to meet that reality where it is and not to demand you to replace it first. So once data are in your platform, you need a common language across all of it. Otherwise, every query becomes a custom data engineering project. SenCore ships with a curated catalog of more than 50 metrics, grouped by domain, air quality, meteorology, water, soil, and so on. So every sensor maps into that shared schema at the injection time. That sounds boring, but it's actually the central unlock for the whole platform, because once everything speaks the same metric language, you can write rule and have it work across your entire network. You can compare stations from different vendors as if they were the same vendor. You can onboard a new station in minutes instead of weeks because the mapping is the only common work. Everything downstream just works. Under the hood, the SenCore is built on two open source projects, workhorses. PostGIS, a well-known database that handles spatial queries, everything in the form of like, give me everything within this polygon or within 5 kilometers of this point. Can be done with this library. Timescale DB that handles time series. For example, we can apply a query like, give me the last 30 days at 5-minute resolution down summed to hourly. You can do this on this platform. Both are proven at a very large scale. Both are used in production by organizations much bigger than ours, and both are fully open. The combination gives you spatial-temporal queries that are surprising hard to do well in other stacks. And critically, because the data layer is open, there is no vendor log in your data. If you want ever to take your data and leave, you could. That's the guarantee that you can do this. And this is the operator's daily view. This is deliberately the most boring slide that you can see, the most boring page you can see in the service. It should be boring because let's say pick a station, see its latest readings, see its history, see its metadata, all in one place. This is designed that way for the person that walks in the office in the morning and needs to know in 30 seconds if everything runs well or anything is wrong. We will spend some time on this during the demo. And you can apply also rules and cross station compare. This is where the raw streams become operational signals. And it's the heart of SenCore as an operational tool. We have three capabilities here. Rule builder, you define the rules in a visual interface. You put 2 or 3 or 10 stations on the same chart and look for regional patterns. You can apply rules to alerts to go through the channels of your team that already uses. All of this with no code, because the people who actually run environmental networks are usually domain experts, not software engineers, and this tool has to match their days. Another thing that we included in SenCore is AI-powered anomaly detection. In most of the cases, rules cover the things that you know to look for. The harder problem in environmental monitoring is the things that you don't know where to look for, and this is the slow drift. the unusual seasonal pattern, the correlated change across stations that doesn't trip any individual threshold, but matters when you see it. SenCore's reasoning engine watches your streams continuously and flags what is unusual based on the station's own history and the behavior of similar stations. And critically, it explains what it found in plain language. We will see an example of this during the demo. Last capability before we dive into the demo, it's real environmental networks are operated by teams and often cross different organizations. A regional, for example, a regional environmental authority working with a research group, a municipality working with a contractor, a national agency working with field operators. SenCore lets you organize stations into groups and share access selectively without exposing your full network to every collaborator. You can apply standard role-based access, but yeah, we will see this in the demo right now. Let me stop sharing the presentation and open the SenCore application. One moment, please. Okay. I think you can see. Can you see my screen now?
Yes.
Okay, perfect. So, oh no, sorry. Okay, here is the dashboard of SenCore. Here you can see on the top you have the menu bar. You can see that you have the dashboard, map view, tab view, compare groups, and advanced tasks. Below you have some cards with some statistics that the total stations that you have in your network. So your online stations, if you have some stations that are in debugging mode, and some if you have some alerts. Next is the section that you can add or configure a new station. For example, if you want to configure a new station, a station that already exists in your list, you can select one and press configure, and you can change the station, some of the information, the name, the description, the location, and some other information here as well. And you can export measurements in CSV format if you want to. And next, you can add a new station by putting here a name. Let's add one like test station. Here, you put a simple description. You add a location. I'm not sure. You can add here your location, some other parameters here, and then you create the station. And then you go next. You can see the station in this list. Let's, for example, say these stations here are live stations, and they stream real-time data. For example, you can see here by seeing the time series information that they are streaming for the last 24 hours, last 5 days, the last month if you want to have an idea what's happening during the past month. Here is the station info on the top. Some information about the specific station, the units that it collects, it saves, live readings of this station with details about the time that the last recording came into the system, time series that we set, table view that you can export this tab to a CSV, and this is where when you add a new station, this is where you when you share the information about how your sensor is can be connected here. You can apply these changes in this section. For example, if it's in HTTP injection, you can find more information about how to do it in this specific section. If it's in MQTT, you can see more information about this here. For FTP, you can connect it with this button by pressing this button and applying the connection details. And here, if you want to connect it to another, this sensor to connect this information to another, let's say, location, you can grab this API key and do it. Here you can apply alerts. For example, you can add a new rule. For example, if the temperature is greater than, let's say, 35 degrees, flag it, alert, put an alert, and a message that you want to see. And when this rule is met, you can see the alert in the system. And here we have an AI analysis that we mentioned before during the presentation, that it runs an analysis on the data that this station has, and you can see some anomaly detection if something happens. For example, here in the presentation of weather station anomalies at Ritsna is, you can see more information about this here. All this analysis is done by real data, and it is explaining here why this text appeared here. Okay, let's move to the next one. Next up, here we have the map view. Here you can see all the sensors that you put in your network. For example, here we have some stations here, and you can see the real-time series of that sensor. If you want to filter specific sensors around a specific location on the map, just press this filter button here. You get a point on the map and apply a radius of, let's say, about 100 kilometers in this area. And now it included only one sensor here, so we can see its readings here as well. Again, we have the table view of all the stations here, and we can also compare in a chart different informations from different stations as well here. You can select them from the list, or you can pick them from a map. You can see the information depicted here in a chart. Next, as we said, you can create groups and give a group name and assign to different members here to have access to the specific stations that you want to share. Next, we have here if you have a CSV table with information from the station, you can download the CSV template here that gives you guide how to format your information from your sensor, and you can upload it here, and you can see the information as you see the data coming from the stations here. So that was the presentation of SenCore. Let's move to the EAGLE now. Give me one moment to share my screen again. Okay, can you see my screen? Yes.
Yes.
Okay, let's move to EAGLE now. EAGLE is the second service, and it's the satellite counterpart to SenCore. When SenCore handles sensors on the ground, EAGLE handles what's coming from above. This is a no-code geospatial AI for observation processing, model training, and inference. The intended audience for this service is anyone who needs to extract structured information from satellite imagery without standing up a custom Python pipeline. That includes remote sensing analysts who can code, but they don't want to. Domain experts who cannot code at all, and engineering teams who want a faster path from idea to production. One moment. Okay. Every EAGLE project follows the same four-step spine. I want to see this because everything, the platform is organized around these 4 steps. We have the data source. You can pick Sentinel-2 images. You can upload your own data. You choose your area of interest, and you can choose your timelines. You can download new satellite data. And next, we have the process. You can create composites, band math, normalization, clipping, or masking. This is the unglamorous work that gets satellite bands into a form of a model that can consume, that can interact with. Next, we have the AI models that apply. You can apply a pre-trained model out of the box or apply one if you fine-tuned on your own data. And this is the inference step. And we have also the outputs that you can produce masks, polygons, statistics, export them as GeoJSON files, as charts, or a report-friendly file. And all these 4 nodes, tools from these 4 categories are connected on a canvas. And you will see that in the next, on the training, how this workflow works. Those 4 steps in the previous slide are picked from 6 families of reusable nodes, from data sources, pre-processing, models, analysis, and post-processing and exports. The mental model here is like this tool is like working like a geospatial Lego. You drop nodes into your the Canva. You wire them together in the order you want, and you can run the pipeline. The reason that this matters is that the same 6 families cover every workflow that you will ever need or build in EAGLE. The canvas itself, which is what the user actually interacts with, it's like a drag and drop chain. Most of the tools you don't need to know any Python to write any script. The layout you will see in this demo is a node palette on the left. You can see all the tools that we included in the platform on the left side. In the middle and then in the other part, there are two palettes, node palettes. You will see where you build the pipeline and all of your work flows. On the top, you will see a menu bar along with the run button that you can start running the workflows. We build this. We deliberately make this look like this and match the feel of other workflow builders that people may have seen before in order to have them feel more familiar with this kind of workflows. We included in EAGLE. EAGLE ships with 4 geospatial foundational models out of the box, including TerraMind from IBM, ESA. Without going too deep, TerraMind is an any-to-any modality, which is the new standard for observation models. It can move between optical, radar, and other modalities natively, which used to require 3 separate models. The point I want to make here is that we are standing with the giants here. We are not training models from scratch, as we should, and you shouldn't be, because the foundation models have already absorbed an enormous amount of generic observation structure. And here you are fine-tuning from a strong starting point, which is the difference between weeks of work and months of work, and the difference between a model that can generalizes and one that overfits in your training data. Before the fine-tuning comes up, a lot of users don't need to. EAGLE has a library of pre-trained models ready to run on any area of interest and any date. For example, flood maps, burn scar detection, land cover classification, water body detection, and a growing catalog of these tools. The user experience is simple. You can pick your area of interest, pick your date, choose a model from the catalog, and hit run. The result comes back as a masked layer over your image and with a confidence score per pixel. For a majority fraction of use cases, for example, emergency response, regular monitoring, baseline assessments, that's the entire workflow. You don't need to think about training your data. You don't need any labeled exams. You just need an answer. When the pre-trained models aren't quite right for your specific region, season, or class definition, you can fine-tune your model. The rule of thumb that we've seen across deployments is that pre-trained gets you around to 8% of where you need to be, and fine-tuning closes that gap. The workflow is to upload your labeled training set, pick which foundation model you want to fine-tune, configure a few hyperparameters, and start training. The system handles the clumping, the data splits, implementations, validation, checkpointing, and you watch a loss curve and a few sample predictions. Decide when you are happy, and the fine-tuned model becomes available in your model library alongside the pre-trained ones. You can then use it in any workflow exactly as you use the stock models that we include in EAGLE. We have two different analysis capabilities that turn model outputs into the kind of number of decision maker actually wants. We have spectral analysis, per pixel indices like NDVI for vegetation, NDWI for water, plus custom band math if you have your own indices. This is your bridge to the existing remote sensing literature, where the most publishing work is built around these indices. We have also zonal statistics. You can aggregate over polygons and get the mean, median, distribution, area count. For example, what percentage of this district is flooded? What's the average permit severity across this protected area? This is where you go from a raster mask, which is a model output, to a single number that goes into a report or a dashboard. We included also two other technical capabilities, which included also open SR super resolution that pushes Sentinel-2 from its native 10-meter spatial resolution to 2.2 meters. This is useful when the underlying resolution isn't quite enough for the features that you are trying to extract, like building outlines, narrow rivers, small agricultural plots. Okay. The last capability slide before the last demo of EAGLE is the two features focused on the last mile. We have included an LLM assistant, which is a co-pilot for workflows. You can describe in plain English what you want to build. For example, build a workflow that detects burn scars in this region, and it scaffolds defines the pipeline for you. But you still need to review it and adjust it. And this is just to help you and don't start from a blank canvas. This is particularly powerful for and useful for new users who know what they want, but they don't know how the EAGLE know vocabulary works, and have an understanding about how they can build their workflow. And we have also the sharing. This is one link sent for workflows and results. You can send a link to a colleague or a stakeholder, and they can see the output without provisioning an account, without installing anything. Both of these are about reducing the friction between building a workflow and getting value from it. So let's see EAGLE in action right now. Let me stop sharing presentation and start sharing EAGLE. Okay, I suppose you can see my screen now.
Yes.
Okay, this is what you, let me clean first. Clean. Okay, this is the screen that the user will see after logging into in EAGLE. On the left side, as you can see, is the node palette, where you can see all the available tools in the different categories that I mentioned during the presentation: data sources, processing, AI models, inference tools, and outputs. You can add the nodes in the main screen here by drag and drop, or by double click them, and they go straight to the screen. You can see here below on the bottom left corner a map of how the workflows appear in the screen here. On the top, you have a menu of to see your projects here, and the workflows saved here as well. On the left, here on the left side, down on this panel, you can see these buttons here. You can check your files. See here in the catalog with the folders and the files that you have in your project. And the model registry, that you can see all the models that you trained during in EAGLE. For example, here also you can see that the AI assistant that appears here. For example, if you don't know what to build, you can press this button and you can see you can interact like interacting in any other LLM. For example, you can use any of these examples here, like detect change between two images, and press generate workflow, and it will see and check all the tools and propose what nodes you need to do this work that you wanted to do. So by applying to Canvas, those tools are inserted in the Canvas. So let's see some examples here that I prepared for you in the next few minutes. For example, I want to show you a change detection workflow that we built here. You can add, you should add raster inputs that you load the data in your Canvas. I will browse to find two different images before and after an event that I want to see the change detection, to spot changes in an area. This is an urban area in Thessaloniki that happened a large urban expansion during the past years. So we get scheduled images from the year 2019 and 2025. I'm adding these images here. After adding the image, you can see that the tool pops up a window to let you know that it's going to add some metadata here. If you have something, if you upload an image that you captured by yourself, you can apply the metadata that you want here and press save data. Next, because the change detection tool node wants specific bands, we applied a band selector node here, which we are going to select the different bands. Yeah, as I'm removing the bands of the Sentinel-2 images, you can see that the tool flags some errors here, some errors that we need to fix. For example, here it wants these bands to fix here. And it wants in a specific order, red, green, and blue. Let's do the same for the other image as well. Red, green, and blue. Everything is green. You can put a name on this run here as well. And I've run this before, and this is why you can see that detection complete, but I will again to see how this works. You can see that when the system runs well, you can see this visualization here that and saying this that the tool is running. Let's wait a bit. The run has been completed, and you can see that it detects 41 instances. We can see here the result. You can see here the comparison map. Comparison map, earlier and later image. You can see here indicates probability-based change detection. You see some more information here that help us understand what happened in the images. And we can get a report on some other statistics useful for people that know what they're doing. This was a simple run. But you can expand it as much as you want. Let's save this and open another one. Let's see that we have a high resolution image, and we want to detect some objects in that image. For example, here we have a very high resolution image from Riyadh in the capital of Saudi Arabia. Again, we accept here metadata. And we want to detect the pools in an urban area that appearing in the image. And we want this to use this for us to use in another analysis, let's say. And here it pop-ups up to this window, and by just text prompting, let's say, find the pools. To apply a confidence threshold, let's say put 0.5 here. The model is going to find any pools in that area. Okay. As you can see, the model detects all the pools in that image. You can save the masks to the node. And you can download this as a combination of raster masks and the vectors again in order to use it for training or fine-tuning another model as well. You can also detect, to tell the model to find some other objects here, like green. That's it. Station. You need to wait some time because, okay. And you just see that it detected some areas. In some other areas, it failed to detect. But if you change the threshold, you will, for sure, I guarantee you that you will be able to detect all the green areas in this image as well. You can also tell the model to detect fields, football fields, roads, cars, solar panels, etc., depending on the work that you want to do. And let me run another model, another workflow as well. For example, you want to detect water in an area. Let's say that you have some lakes in an area, and then you want to find the extent of that lakes. For example, here I downloaded and loaded here a Sentinel-2 image of a lake in Greece. You add the flood water inference model, flood water detection inference model in the canvas, and if you want to vectorize its output, you can also include a tool that vectorizes the outputs. So by pressing run, we can see that the model detected. Let me go a little bit more zoom. Okay. We can also see here the Sentinel-2 image that we used for the model. And here we can see the detected water in this image. So with the yellow mask that we can change the opacity is the water detected in this area. We have also here some statistics with the model confidence 98.6%. And we can also save the vectorized polygons in the vector format that we can use it further in other GIS software for further analysis if you want to. So if you got an idea of how EAGLE works, you can expand these workflows as much as you want. And here we also have AI models that you can train with your own data, labeled data, and you can fine-tune the models that we included in this service. So this goes from my side.
Okay, very good. So thank you very much for your presentation, Dimitrios. Now we're entering, I guess, the more interactive part. So I see that there are quite a few interested participants to know more, and I see there that there are some people already raising their hands, but please indicate your questions in the chat. In the meantime, before we start going into that, let me just share a quick survey. Couple of questions that would help us understand how you're receiving the information from the webinar so far, and also it would allow us maybe to put you in touch in case you want to know more with our service providers. Now, we have today as well, aside from the previous speakers, also joining us, we have Apostolos Agrafiotis present, and we also have Barbara Scarda. Yes. So, yes, I see from the polls that are now active. Okay, a couple of people have started answering. Yeah, please fill that in. Okay. Let me just see. Okay, in the meantime, did you want to already, do you want to perhaps take the first question already? We have the first question from George Hammerer. What are the costs for using the services? In fact, very nice services as well. Nice comment there. Is there something that we can share already? Oh, sorry. Your audio.
You're not.
Okay, bear with us for a few moments. Okay, I see we're.
Sorry.
Yeah, now you're there. Okay, good.
Both services are completely free in this phase of Destination Earth, so you can easily use it.
Excellent. So I hope you heard that, George. Free, wonderful services. Okay. We have a question from Hoyan Shi. If you can type your question in the chat, that would be great. Otherwise, if you're having an issue, maybe we can give you the floor really quickly. In the meantime, I see we have a backup question coming up. Okay, so what type of users can benefit the most from SenCore EAGLE? Is there someone that can provide a quick overview?
Okay. When we designed both EAGLE and SenCore, we tried to make it very diverse in order to have an opportunity both EO expert and not EO expert to be easily use them. So in one side we serve let's say data scientists, developers, researchers who need some repeatable pipelines and to use the state-of-the-art foundation models without having all this noise of building the infrastructure and all this. On the other side, of course, we actively empower the public sector stakeholders, some policy-oriented users, and of course the non-EO experts to use our two services. Both EAGLE is entirely no code, and of course SenCore translates using the LLM that it has, translates some complex sensor anomalies into plain language in order to give anyone the opportunity to use them easily and adapt it.
Okay, thank you. We have a question from Antonius Parasiris. Can we find somewhere the examples you showcased with the workflows in EAGLE to import and test?
Let me answer this question. No, you cannot find the exact examples that I presented here, but you can use the AI assistant to ask it what would you want to build. For example, an object detection workflow, and it will bring the nodes in the canvas that you can use by yourself. But if you want the images, the high resolution images, you can download by yourself to do this. Or if you want to use Sentinel-2 images, you can also use the node specifically built for downloading Sentinel-2 through EAGLE. So all the tools are available there, but not exact. You cannot find the exact examples that are used here.
Okay, good. In our last 2 minutes, I invite the audience to please share quickly your questions before we have to close the webinar. Until then, maybe we can answer this last one. What are the main problems that the service aims to solve?
Let's say we focus on four, let's say, operational bottlenecks. The one is the data fragmentation, to bring together satellite, climate data, real and in-situ data into one unified space. The second, let's say, bottleneck we try to solve is the operational latency by providing real-time processing validation and fast querying for the sensor network data. The other one is the AI workflow friction by transitioning the data from the data ingestion to the model training and also the deployment without having a lot of disconnected tools. And the fourth one is the lack of repeatability by giving the users the opportunity to make, let's say, a project scoped environments where data, model runs, and parameters are completely traceable in one service.
Okay, thank you very much.